welcome back to our calculus lessons. Today our main focus will be putting position, velocity, and acceleration all together. We will be looking at real-world problems and application problems. If you guys need a refresher of the meaning of them, I have written them down on the board. But if you need a more in-depth refresher on how to apply them or how to use them in equations, please check out the videos in the description. All right, let's get started with today's lesson with some practice questions.
Okay, so let's get started with this question over here. Let me read out the question so you guys have a better understanding. A toy rocket is launched straight up so that the height s in meters at time t in seconds is given by st equals negative 5t squared plus 30t plus 2. What is the velocity of the rocket at t equals 4? Now, first thing that you guys should think about is the question, which says at t equals 4. Because there's only one point, you should automatically think about doing instantaneous rate of change and not average rate of change. Why? Because we're not looking for the rate of change between 2 points. The next thing that you guys should look at is the equation that's given. We're looking at st. That means we're looking at the position time graph. When we are solving for velocity, we know that it's the derivative of the position time graph. So to approach this question, the very first thing that we are going to do is use first principles to get the rate of change. And if you recall the first principle, it is limit h tends to 0. And instead of using f of x, it has it in s of t. We're going to say s of t plus h minus s of t over h. Then on the side, I'm just going to simplify both of them. So we have s of t, which is equal to negative 5t squared plus 30t plus 2. And then s of t plus h would then be negative 5t plus h squared plus 30t plus h plus 2. So now let's simplify this. This will become negative 5t squared plus 2th plus h squared. What I did over here was I used perfect squares. And then for the second part, because I don't have to expand by using Pascal's triangle, I could just go ahead and use distributive property to simplify. And that becomes 30t plus 30h. And then I just have plus 2 at the end. After, I'm going to distribute the negative 5 into the equation. So it becomes negative 5t squared minus 10th minus 5h squared plus 30t plus 30h plus 2. So using both of the equations that we see over here, we're going to plug it in to our first principles formula. So we have limit h approaching 0, and then negative 5t squared minus 10th minus 5h squared plus 30t plus 30h plus 2. Subtract that whole thing with negative 5t squared plus 30t plus 2 divided by h. So now from here, what I'm going to do is apply distributive property with the negative, and that gives me limit h approaching 0, negative 5t squared minus 10th minus 5h squared plus 30t plus 30h plus 2 plus 5t squared minus 30t minus 2 over h. Now, this negative 5 and this positive 5 are able to cancel out. The positive 30 and the negative 30 would also be able to cancel out. This 2 over here and the negative 2 over here also cancels out. So that leaves us with limit h approaching 0, negative 10th minus 5h squared plus 30h over h. So from here, I'm going to take h in common. So I have limit h approaching 0, h negative 10t minus 5h plus 30. Now, you guys might be wondering, well, I could have also taken 5 in common. Why didn't I? Well, we need to plug in 4 into the equation after, and I just don't want to deal with expanding again. So this is my way of making it less work. So now I'm able to cancel out the h's. And you guys need to remember, if you're not able to cancel out that denominator h, that means you did something wrong. Either your expanding over here was wrong, or your distribution over here was wrong, or you missed a number or a letter or a variable, which caused the h not to cancel out. So you always need to make sure that the denominator h cancels out. So now we have limit h approaching 0, negative 10t minus 5h plus 30. And finally, we get to plug in 0 for h, which is going to be negative 10t minus 5 times 0 plus 30, which gets simplified to negative 10h plus 30. Now, this over here is our slope, meaning our velocity equation. So this is vt. And our question was, what is the velocity at 4 seconds? So I made a mistake over here. That's not h. That is t. So our question was, what is the velocity at 4 seconds? So all we really have to do is plug in v4 into the equation. And when we do, we get 10. Now, because it's velocity, you guys need to remember direction is included into the answer. So we would go ahead and answer it by, therefore, the velocity at 4 seconds is 10 meters per second up. Now, how do I know it's up and not right or north. Well, I could have also said north, but the reason why I say up is because we know that the rocket is shot up. So instead of using north, I'm just going to say up. And the